What is it, 151? Awesome, thank you. All right. Let's start with 23. 23, yeah, okay. 3 kilogram ball is dropped from a roof of a building that's 176.4 meters high, While the ball is falling towards the earth, a horizontal wind exerts a force of 12 newtons on the ball. Now, this kind of sounds like a one-dimensional problem, right? Where you're just dropping a ball, except that there's a silly wind. So it's kind of...
Oh, like a extra margin?
Yeah, it's a projectile motion question. So here's the thing, though. Do you remember when we were doing projectile motion problems? Oh, so long ago now. And we had the little device, and there was one ball bearing that fell straight down, and one that went straight across and down. And then we filled out our little chart. We said that acceleration in the y direction would always be negative 9.81. And then I said that acceleration in the x direction would always be
0.
except now. Okay? It was like 99.9% of the time. This would be the other part of the time. So this is what's happening in 52, or excuse me, in 23. You've got your building and your ball, and it's feeling some forces, right? It's feeling a force this way. That's the force of the earth on the ball, F sub g. And that's going to cause an acceleration in the y direction, right? We know that acceleration. So if we were going to fill out the dy, vy, and ay stuff, this is going to be negative 9.81 meters per second squared. But now we've got a force of the wind on the ball too. And then when we have our dx, vx, and ax, now we have some acceleration in the x direction. Yes, exactly. Because in the x direction, F net in the x direction is equal to m sub a in the x direction, which is just that 12 newtons. Is that better? Does that get you where you need to go?
So, because we're trying to find time, so then we just use... Oh, so it's just basically one of my
Exactly, yes. So it's just a projectile motion problem. Except in the x direction, which is part B, Vx is going to start off at 0, but it's going to accelerate now. Okay. So this will be 0, and this will be something like, what was the mass? 3? 3 times. So 12 divided by 3 is 4. Total acceleration of 4 meters per second squared. Is that all right? Does that get you where you need to go on that one?
Yes.
Okay, wonderful. Excellent. Bless you. And then the other one was 52. Let's take a look. The boat moving through the water, is that what you're talking
I
about?
might know how to do this now, but...
Should we just look at it quick?
Confused at the time.
Okay, well, let's take a look. A boat moves through the water with two forces acting on it. One is 2,100 newtons forward push by the motor, and the other is a 1,800 newton resistive force due to the water. What is the acceleration? Should we go through it? Do you think? I don't know, what are you thinking? What are you thinking? Do you want to go through it? We certainly can.
Sure.
Okay, so here's my boat. I've got the force of the water on the boat, and I've got the force of the resistive. I don't know what we call it. I'm sorry, this is the motor, right? And this is the water. So this one is the 2,100, and this one is the 1,800. Does that make sense? So then you could find the net force acting by subtracting the two.
Okay, yeah.
And then F equals MA? Okay. Cool. Any other questions? Yes, ma'am. You may. Anything else? Good to go? Wonderful. All right. Cool. Hold on.